Hi, I'm Peyton Schaefer. So this is going to be my code review for the second homework assignment for CS444 operating systems at Clarkson University. The second homework problem is the producer-consumer problem, which is basically just a problem that has to deal with shared access to critical regions and just making sure that only one process is accessing a critical region at a time, because if multiple processes operate in the same critical region at the same time, they're going to have inconsistent data, or even could call it some kind of deadlock or something bad. So we just want to prevent that and have mutually exclusive critical areas. So the solution that I used for this problem is going to use pthreads and something called a mutex, and this will solve the critical region access problem. So let's just get started looking at the code. So first, we're going to include our standard IO library, the IO stream. So then I'm going to include the queue library. So this is just so we can use the queue, just the data structure queue. This is what I'm going to use as my buffer for the producers and consumers. And then obviously the pthread library. So the pthread library here is going to contain our threads, our mutexes, and our conditions. So it's a very important library here. And then, of course, using the standard namespace. So for now, we're going to define max as 10. So this number max is going to be the number of the amount of items that the producer produces and the consumer consumes. So just how many times that loop runs for. So we create some global variables first. So we're going to have our pthread mutex t. So this is just declaring the mutex. So I call it mtx. So this is declaring our mutex. And then we have two condition declarations. So ccond and pcond. Those are for the consumer and producer. So these conditions are for signaling between the two parties. So the producer can signal something to the consumer and vice versa. And then lastly, we have this q, which is an int q. So it's going to consist of all integers, and this is what the buffer is going to be. So this is the shared buffer between the consumer and producer. Okay, so let's look at our functions now. So the first function that I have here is the producer function. So the producer function is going to loop, obviously, max times, and each time it's going to add something to the buffer. So, and it takes void star args, but we don't even need those, so it's okay. So we have this for loop that goes from 0 to max. So this is putting the item into the buffer max times. And next we have to create the loop. So next we lock the mutex. So we go down on the mutex. This is ensuring that the critical region is locked and only the producer is in there. So once the mutex is locked, no one else can enter. So that's good. So then we have this while loop here. This is to check if the buffer is empty, and we're waiting for a condition from the, or while it's not empty. So this is basically just waiting for the producer or the consumer to remove everything from the buffer, and we're just going to wait for that condition. So the consumer, and later in the consumer function, the consumer is going to call this to let the producer know that he can now access and do some work. So then we are going to push an item onto the buffer, in this case I, and then we just print this out just so we can keep track of it. So the producer produced whichever one on the line, and then we unlock the mutex, letting the critical region people have access to the critical region again. And then we use this pthread condition signal, and we signal the consumer to wake up, which is going to be like in this kind of loop area, and let them know that the mutex is unlocked, and if they need to get in there, they can get in there. And then at the end, we just return null, because when we compile, it wants some kind of return statement. So just returning null makes it so it compiles with no warnings. So the consumer function is pretty much exactly the same as the producer function. There's just a few differences. So it's, once again, we have the same arguments, and then we do a for loop of the exact same size and stuff from the producer function. Then, of course, the consumer is going to try to lock the mutex so that it can go get exclusive access to it. So we have this loop again that's going to be waiting for a wake up signal from the producer. So of course we're waiting for this C condition on this mutex. So this is the same as this one, but just this time the consumer is waiting for the producer, and up here in our producer function, the producer is waiting for the consumer. So next, I'm going to look at the item on the front of the buffer. So this is basically just so I can print it out. So we read in the item on the front of the buffer, and then we pop that item off the buffer so it is no longer in the buffer anymore. And then we print out that the consumer consumed said item. So it's just going to be item whatever the producer put in, and that's just going to print out that number. And then, of course, after that, we are going to then unlock our mutex so that the producer can have access again, and then signal to the producer condition thing variable so that we can signal to the producer. And again, return null for the same reason. So this is the producer and consumer function. This is kind of all the backbone of the code. The mutex locking and unlocking and the signaling is what allows for that mutual exclusion of the critical region, and just allows so there's no inaccurate data. So now if we look at our main, it's not too bad. So we initialize our pthreads for the producer and the consumer, respectfully. Pro is producer, con is consumer. So now we need to actually initialize our mutex and our conditions. So we use this, for our mutex, we use this call called pthread mutex init, which will initialize the actual mutex so that it can be used. And then we do a pthread condition cond init for one for the pcond and ccond, which is for the producer condition variable and the consumer condition variable. So it's just initializing it so it's ready to use and stuff. So next we want to create our pthread, or both of them. So the first one I'm going to create is the producer one, and we feed it our producer function, and we say null because there aren't any arguments to feed it. It just loops through and does it all itself. And then in the same way, we create our consumer function, which again, or consumer thread, which will will run the consumer function. Again, null because there are no arguments. So then after that, we want to join the two threads and make sure that they are finishing at the same time so we can actually see the output that they have, and we're not finishing too early. So this pthread join call for producer and consumer just ensures that everything's synchronized and that we're going to wait for everything to finish the operation so we can actually see what happens. And then at the very end, I just decided to use the deconstructor on the mutex and the condition. So maybe for this program, it's not as important, but on a larger scale project, it would definitely be important to deallocate this memory and destroy these. So we use the pthread mutex destroy to destroy a mutex, and then pthread condition destroy to destroy the two conditions we have, which is the producer condition variable and the consumer condition variable. So this is just all the code. So I guess from here, we'll do a little example of how it's going to run. So let me open up my terminal. So first, let's just make sure it's compiling. So G++, call it prodcons for producer consumer, and then producer consumer.cpp. So as we see, it compiles totally fine. So as of now, it's just going to run 10 times. So let's just see what it outputs. So producer consumer. So when we look at our output, we can see that they really are taking turns, and this mutual exclusion of the buffer is truly working. So the producer pushes 0, and then the producer then will obviously signal the consumer. So then the consumer has its turn with the buffer. So then this consumer is going to consume the 0 and take it out of the buffer. And then they basically just repeat this process from 1 all the way up to, from 0 all the way up to 10, with the producer producing a number, and then releasing access to the critical region, the consumer taking access to the critical region and consuming that number and removing it from the buffer so that the producer can produce a new number, and the cycle continues 10 times. And that's the output. So I guess we can show this maybe with a little bit of a bigger number. So let's say we'll do 100 times just to make sure everything works, even if we scale it up. So we're going to recompile it. Everything seems okay. Let me clear my window, and then we will run producer consumer. And as we see, it looks like it has done it all good. So if we come to here, 0, 0, 1, 1, 2, 2, it looks like the producer is producing something. The consumer consumes it right afterwards. And the critical region only is accessed by one process / thread at a time, I guess in this case, thread. So as we see, we can go all the way up, still very consistent all the way through. Like we stop at 83, producer produced 83, the consumer consumes 83. And then we can go, of course, all the way down to the bottom. As we can see here, the producer produced 100 and the consumer consumed 100. And that's everything working fine. Yeah, so thank you.